we are going to learn how to solve logarithmic equations. Now, basically, there are two different types of logarithmic equations, and depending on the type that you have, that determines your process for solving it. So the first type, we say all terms have a logarithm, and it's either spelled L-O-G or L-N, just depending on the problem. And if you'll look at my examples here, this would be an example where all terms have a log. Okay. The second type is where not all terms have a log. And again, whether it's log or a natural logarithm. And if you look at my second example, that is where not all terms have a log. So the approach is different based on which type you have. If all terms have a log, your goal is to get a single log on both sides using your properties. Now, sometimes that may already be done for you, such as in this example that I'm showing you here. And sometimes it may not, and we'll look at some future examples where it's not. Whereas, if not all terms have a log, then you can't get a single log on both sides, so your goal is to get a single log on one side. Again, using your properties of logarithms, and we'll talk about how to do that in just a minute with that particular example. Okay, so once you have a single log on either both sides or one side, if it's on both sides, then basically what we say is that there's a theorem. If you have the log of one expression and it's equal to the log of another, then you can set those expressions equal. So that's the second step here, is that you're ready to set their expressions equal. And so you'll notice in this first example, since I already have a single log on both sides, I'm ready to just simply say x plus 2 must equal 8x. I can set the expressions equal, and we'll come back and finish solving that in just a minute. If you only have a single log on one side, then your strategy is to change it into exponential form. And we'll show you how to do that in just a minute with that second example. So let's go ahead and finish solving this first one. So we had all terms had a log. We already had a single log on both sides, so we set the expressions equal. Now we're simply solving for x. I'll subtract x on both sides. 8x minus 1x leaves me with 7x. And then if I divide both sides by 7, I get the fraction x is equal to 2 over 7. And so in this case, it says we can write our answer as an exact expression or in decimal form to 4 places. This would be an exact expression. You do want to check your answers because remember, you cannot take the log of a negative number. So you want to make sure when you plug that value of x back in, everywhere it exists, that that is not causing you to take the log of a negative number. And in this case, it's not. So the solution should be valid. Okay, on my second example, not all terms had a log, so I have to get a single log on one side using my properties. Notice those two logarithms are being subtracted. When they are being subtracted, in order to put them back together as a single log, we actually have to divide their expressions. So the x plus 1 will go on top since it came first. X will go on bottom since it came second. And of course, that's equal to 5. So now that we have a single log on one side, we are ready to change it into exponential form. Remember that when a logarithm is spelled as ln, it is understood to have a base of e. So when I go to change this to exponential form, my base is e. It gets raised to a power of 5. And I say that's equal to x plus 1 divided by x. I have to get x by itself, but before I can do that, I need to get rid of the fraction, so I'll actually multiply both sides by x. So I have my x times e to the 5th is equal to x plus 1. And I need to get the x's on the same side, so I will actually subtract x on both sides. And let me come up here. So I have my x times e to the 5th minus the x I subtracted is equal to 1. Okay, so notice both terms have an x in common. I will factor it out. Put my leftovers in parentheses. So I have x times e to the 5th minus, when I factor the x away, I'm left with a factor of 1 there. And then finally, to get x by itself, I will divide both sides by e to the 5th minus 1. And then this is a case where you'd probably want to give a decimal to 4 places. And so you'll notice that when I punch this out on my calculator, that with 4 decimal places, I'm going to say the 8's going to have to round that up. So my 4 decimal places would be 0.0068. And again, make sure that you look back at the original problem. When you plug it back in, make sure that it is not creating a negative expression for you to take the log of.